we are having a good time here at the Johnson Kendall Video Hour.
But it's not an hour.
Yeah. All right, people, part 2 of 4.8, complex numbers. All right, we're going to talk about something called conjugate. Conjugate is used to create a product that's a real number, which means you have to get rid of the i's. I's are imaginary. We want real. Conjugates are binomials, so there's two parts to them. They have the same numbers but different signs. So, for example, let's get rid of that. I have this right here is a binomial. We got two binomials going on here. One there, one there. They have different signs. So, I'm going to FOIL this out and see what happens to the i's. So 3 times 3 is 9. Then we do the outside, that's 6i. Then we do the inside, that's negative 6i. Then we do the last, which is negative 4i squared. Putting those together, I have 9. These cancel out. Then I have minus 4, but what is I squared?
It is negative 1.
Okay, so negative, negative makes a positive, so this is actually 13. So let's see how that became a real number.
How often do you use conjugates in trig, for instance?
We use them quite a bit, actually, because we're always getting complex fractions, and we got to get rid of the imaginary parts, or the radicals, or all kinds of things.
Okay.
So it's the best way to get rid of those kind of things. All right, in a problem like this, we need to get rid of the I in the denominator. So the best way to do that is with the conjugate again. But you only worry about the denominator. The numerator, it can be anything. Those can have i's in it. You can't have i's in the denominator. So I'm going to do 3 minus 4i, top and bottom. The reason I do both is because really that's a form of 1. Multiplying by 1 doesn't change it, so we're legal to do that. So, foiling the top. 5 times 3 is 15. 5 times negative 4 is negative 20i. Negative 2 times 3 is negative 6i. Then negative 2 times negative 4 is positive 8i squared. Let's do the bottom. 3 times 3 is 9. 3 times negative 4. 4 times 3, and 4 times 4 negative is negative 16i squared. All right, what do you notice about the bottom?
I noticed that your i's will cancel.
All right, so let's get those out of there.
And I also noticed that you have I squared.
Right, top and bottom.
Right, and that's the same as negative 1, so that's going to change those signs.
Right, so on the top, I've got 15. These two can go together as negative 26i. This is negative 1 times 8.
It's negative 8.
Right. Then I have 9. This is negative 16 times negative 1. So that's positive. Very good. So 15 minus 8 on the top is 7. And you have your minus 26i. 9 and 16 is 25. Check the heart surgery idea here. Can you reduce?
I don't think so. 7's prime, so.
Yeah, so we're going to leave that one alone.
All right, so it's simplified because we got rid of imaginary numbers on the bottom.
Right.
All right.
Let's see what the next one is. All right, same deal, and they look the same kind of already, but that's just a coincidence. We still worry about...
Wait. I can't just go like this?
No
Or
way.
like this?
No. It's got plus and minus. You can't do that with plus and minus.
Okay.
That's why we use the conjugate.
Okay.
All right, so we're going to multiply 8 plus 7i.
And you picked that because that's the conjugate of the bottom.
The bottom.
Okay.
That's what you have to worry about. Top doesn't really matter. It's the bottom.
Is that a star?
That is a star. It's a Kendall star.
Oh, all right.
All right, so 8 times 8 on the top, 64. 8 times 7i, 56. 7i times 8 is another 56. 7 times 7 is 49i squared. On the bottom, 64. And plus 56i, minus 56i, and then minus 49i squared. All right, simplifying. On the top, 64. These two together make 112 I. These two, okay, again, I squared is
Negative 1,
times 49.
negative 49.
49. Okay. On the bottom here, another 64. If we did it right, all the i's should go away. Those two do. And then what does this become?
Well, I squared is negative 1, so we're multiplying by 49, negative 49, so it's plus 49.
All right. So we'll put that on the bottom. And then 64 minus 49.
Knew there was a 13.
So 64 minus 49 is 15 plus 112i. And then on the bottom, we have 113. And I don't think any of those can be simplified, so we'll just call it good.
Looks good. All right, let's try one last one. And this one's slightly different. If you notice the denominator, it doesn't really look like the others because it doesn't have a binomial. But what you want to think about, when you have 2i, what that means is the real number part is just a 0. So it still has a conjugate. The conjugate would be 0 minus 2i, which is the same thing as negative 2i. So that's the conjugate that we want to multiply by.
So if it was a negative to start, we'd make it a positive
Exactly.
as its conjugate.
You switch the number that is on the I part, the imaginary part. Okay, so this time it's not necessarily foiling because it's not two binomials. Here we can just kind of distribute here. So I will have, I'm going to take 2 and multiply by negative 2i, so that's minus 4i. And then the next part, that will get a positive 6, and that will be I squared. And then on the bottom, I will put together my negative 2 and positive 2, that is negative 4. I times I is I squared. We will simplify. I squared is negative 1, so that means that that whole thing is really like negative 6. I don't have any like terms. I'm going to write that first because we like the real number part first and the imaginary part second.
Like they wrote I plus B, or sorry, A plus BI.
Correct. And then on the bottom I've got negative 4, and we're multiplying. Remember, that's the same as negative 1. So positive 4 on the bottom. I think I can use heart surgery here. If
Yay.
I look, those will cancel out. They share a factor of 2. So minus 3 minus 2i all over 2 is our final answer.
Very good.
Okay.
Pretty good at that heart surgery. If you go to med school.
I did not.
No. Should have.
Okay, moving on to quadratic formula. So, why do we need these i's? Well, a couple days ago we started working with quadratic formula, and sometimes we got negatives under radicals, and at that point we just said that there was no real solution. And that's correct, but we actually want to find out what are the imaginary solutions. So we're going to do that now.
All right.
Make sure it's in standard form. Our a is 1, b is negative 4, and c is 5. Plugging it into quadratic formula, opposite of b, plus or minus the square root of b squared minus 4ac.
Like how you use the parentheses to watch out for the negatives.
That's right. All over 2a. And notice my fraction bar is nice and big. Covers everything.
Yeah.
4 plus or minus underneath there. I'm going to square the negative 4. That's positive 16. Also, I've got a negative times a positive times a positive. That's going to be a negative. And then I end up with a 20. And then on the bottom, I can do 2 times 1 at the same time. Still working underneath the square root. I do 16 minus 20. That is negative 4. All over 2. Now,
Can we do heart surgery right here?
no, that's a good question, but we cannot. And that is because you can't do heart surgery inside of the radical.
All right, because
Only
it's
with the
not
things
really a
out front.
4. It's a square root of a 4,
Exactly.
which is different. Okay.
So what we want to do is simplify that. Now, it kind of depends what you have. 4 is a perfect square, so we can take the square root of 4, and because there's a negative, we know it's going to be imaginary. So 2i is the simplified version, all over 2. And then I want to check for heart surgery, and I think we can, because now they're not in radicals anymore. Share a factor of 2. 2 plus or minus, you could write 1i, and it's really over 1. So that's our final.
Nice.
You want to try one?
Ooh, can I?
You sure can.
All right.
Okay, here you go.
I love quadratic formula. All right, so our B is -1, and our C is 2. So negative B, opposite of B is 1 plus or minus. B squared, so -1 squared. I did my parentheses like you did.
Good.
4 times 3 times 2 over 2 times 3, because that's your A on the bottom. Working underneath,
1.
1 minus 4 times 3 times 2 is 24. And then a 6 on the bottom. One more time, negative 23 under there. And since 23 is prime, there's nothing it can break into. The only thing we can do is get that little negative out and be excited to be out. Upside down exclamation point. So there.
That looks great.
All right. Good job, everybody. We'll see you later.
Bye-bye.